What is the Big Bang Theory? It is the prevailing scientific model for the birth of our universe, a theory that has captivated scientists and thinkers for decades. It suggests that everything we observe today, stars, galaxies, planets, even ourselves, originated from an extremely hot, dense state billions of years ago, in a moment of unimaginable transformation. Imagine a universe packed into a space smaller than an atom, a singularity of immense potential. This tiny point, full of unimaginable energy, expanded rapidly in a fiery burst, setting the stage for everything that would follow. This is the Big Bang, a moment that marks the beginning of time and space as we know it. The theory doesn't describe an explosion in space, but rather the expansion of space itself, a concept that redefines our understanding of the cosmos. It's a concept that stretches our minds to their limits, challenging us to think beyond the ordinary. The Big Bang is not just an event in the distant past. It's the ongoing process of our universe evolving and changing, a dynamic story that continues to unfold. From that initial burst, everything we know and see around us began to take shape, from the smallest particles to the largest galaxies. The Big Bang Theory is a story of cosmic evolution, a narrative that explains how the universe has transformed over billions of years. It tells of a universe constantly changing, cooling, and forming the structures we observe today, a process that is still ongoing. It helps us understand the origins of galaxies, stars, planets, and even life itself, providing a framework for our place in the cosmos. The quest to unravel the mysteries of the Big Bang is a journey into our own cosmic origins, a scientific adventure that seeks to answer fundamental questions about existence. It's a journey that continues to inspire awe and wonder in every curious mind, a testament to the enduring human spirit of exploration and discovery. The idea of the Big Bang didn't appear out of thin air. It emerged from decades of observations and groundbreaking discoveries. In the 1920s, astronomer Edwin Hubble made a monumental observation. He noticed that galaxies are moving away from us. The farther away they are, the faster they recede. This observation led to a revolutionary idea. The universe is expanding. If the universe is expanding, then logically, it must have been smaller in the past. Like rewinding a film, scientists theorize that if we go back far enough, everything in the universe must have been compressed into an incredibly dense and hot state. This idea was first proposed by Georges Lemaitre, a Belgian priest and physicist. He called this initial state the primeval atom. Lemaitre's work, along with Hubble's observations, laid the groundwork for what would become the Big Bang Theory. These pioneers dared to challenge the prevailing view of a static and unchanging universe. Their insights sparked a scientific revolution, forever changing our understanding of the cosmos. They taught us that the universe is not static, but a dynamic and ever-evolving entity with a beginning and perhaps an end. The Big Bang wasn't a single event, it was a process. The early universe, just fractions of a second old, underwent a period of rapid expansion called inflation. During inflation, the universe expanded exponentially, growing from a size smaller than an atom to a size larger than a grapefruit in a fraction of a second. This dramatic expansion smoothed out the early universe's energy and density, creating the uniform conditions we observe today. Imagine blowing up a balloon. The dots drawn on its surface spread out as it inflates. Similarly, the universe's rapid expansion stretched out any initial wrinkles, leading to a remarkably smooth cosmic structure. Inflation is a key concept in modern cosmology. It explains several observed features of the universe, like its remarkable uniformity and flatness. This rapid expansion is crucial for understanding the universe's large-scale structure, the distribution of galaxies, and the existence of cosmic background radiation. The concept of inflation tells us that the universe we observe today is just a tiny fraction of a much larger, possibly infinite cosmos. It hints at a vast, unknown universe beyond our current observational limits. Section 4. Echoes of Creation, the Cosmic Microwave Background. The Big Bang Theory makes a remarkable prediction. If the universe began from an extremely hot, dense state, then there should be a faint afterglow of that heat spread throughout the cosmos, permeating every corner of the universe. This afterglow is called the cosmic microwave background, or CMB. It is a crucial piece of evidence supporting the Big Bang theory. In 1964, this afterglow was accidentally discovered by Arno Penzias and Robert Wilson, two radio astronomers who were initially puzzled by the persistent noise in their data. They found faint microwave radiation coming from every direction in the sky, an omnipresent signal that couldn't be ignored. This radiation, a faint hum in the microwave part of the electromagnetic spectrum, is the leftover heat from the Big Bang, now cooled to just a few degrees above absolute zero. It's like the faint echo of the universe's fiery birth, still resonating through the cosmos billions of years later, a whisper of the universe's explosive beginning. The discovery of the CMB was a major triumph for the Big Bang theory, providing a solid foundation for our understanding of the universe's origins. It provided strong evidence that the universe did indeed begin from a hot, dense state, confirming predictions made by theoretical physicists. It also offered a snapshot of the universe as it was just 380,000 years after the Big Bang, a time when the first atoms were forming. The CMB is a treasure trove of information about the early universe, a cosmic relic that holds secrets about the universe's infancy. By studying its tiny temperature fluctuations, cosmologists can learn about the universe's composition, age, and evolution, unlocking mysteries that have puzzled scientists for decades. Section 5. The Matter Mystery. Where did all the antimatter go? One of the most puzzling mysteries in cosmology is the matter-antimatter asymmetry. This enigma has baffled scientists for decades, as it challenges our understanding of the universe's fundamental nature. According to particle physics, every particle of matter has an antiparticle with the opposite charge. These antiparticles are identical in mass, but opposite in charge to their corresponding particles. For example, the negatively charged electron has a positively charged antiparticle called the positron. When these particles meet, they annihilate each other, releasing energy in the form of photons. The Big Bang should have created equal amounts of matter and antimatter. This balance would mean that the universe should be filled with energy from these annihilations. However, our universe is made almost entirely of matter. This observation raises a significant question. Where did all the antimatter go? Why do we see a universe dominated by matter instead of a perfect balance? This remains one of the biggest unsolved problems in physics. The disappearance of antimatter is a mystery that continues to intrigue and challenge scientists. Scientists believe that a tiny imbalance between matter and antimatter in the early universe led to the dominance of matter we observe today. This imbalance could have been caused by slight differences in the behavior of particles and antiparticles. This slight asymmetry, perhaps just one extra particle of matter for every billion pairs of matter and antimatter, allowed matter to survive and form the stars, galaxies, and planets we see. Without this imbalance, the universe as we know it would not exist. Understanding this asymmetry is crucial for unraveling the early universe's evolution and the fundamental laws of physics. It could provide insights into why the universe is structured the way it is. The search for the answer takes us deep into the heart of particle physics and the nature of fundamental forces. Researchers are conducting experiments and developing theories to explain this phenomenon. It's a quest that could reveal new particles, new forces, and a deeper understanding of the universe's very essence. The journey to solve this mystery is ongoing and promises to expand our knowledge of the cosmos.